Hello everyone, my name is Kishan Agarwal. I am from CSCB. Today I am presenting my concept video of linear algebra and calculus, and my topic is odd and even function. So let us see what is function first of all. Definition of a function. Let A and B, the non-empty set, a relation f from A to B is called function or mapping if for each element of set A there exists a unique element in set B written as f from A to B. If f of A equal to B, whereas A belongs to set A and B belongs to set B, then B is the image of A and A is the pre-image of B. Remember that the element should be unique, then only it is defined as a function. So see, what a function in mathematics. A function is a relation between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. Let A and B be any two non-empty sets. Mapping from A to B will be a function only when every element in set A has one and only one image in set B. See, in the first figure we can see 1 is mapped to P, 2 is mapped to Q, and 3 is also mapped to Q. That means one function do not have two values. So it can be considered as function, whereas in the second figure we can see that 2 is mapped to P and also Q, so it is not a function. A function at particular number cannot give us two outputs, so that's why it is not considered as function. Whereas in the first case Q is mapped to 2 and 3, so for two different inputs we can have the same output, but for single output we cannot have any kind of 2 or 3 outputs. There will be unique output. So another definition of function is that it is a relation of f in which each element of set A is mapped with only one and only one element belonging to set B. Also in a function there cannot be two pairs with the same first element. So what are the types of functions? There are many kinds of functions like one-one function, which is also known as injective function, many-one function, onto function, that is surjective function, into function, polynomial function, linear function, identical function, quadratic function, rational function, algebraic function, cubic function, modulus function, signum function, greatest integer function, fractional part function, even and odd function, which is our topic, and periodic function, composite function, constant function, and identity function. So in this video we are going to discuss only about even and odd functions in detail. So these are the graphs of some functions. In first graph it is identity function, where we can say that A is equal to B, that is f of A equal to B. Constant function, every time f of A is equal to some particular value, that means every input has same value, there is same output. Polynomial function, quadratic function, cubic function, rational function, and modular function. Now let's begin with the topic, that is odd and even functions. So there are different types of functions in mathematics, as we have seen. We can determine whether a function is even or odd algebraically or graphically. Even and odd functions can be checked by plugging in the negative input, that is minus x in place of x, into the function f of x and considering the corresponding output value. Even and odd functions are classified on the basis of their symmetry relation. Even and odd functions are named based on the fact that power function, that is f of x equal to x power n, is an even function if n is even, and f of x is an odd function if n is odd. A function can be even or odd, or both even and odd, or neither even or nor odd. First of all, what are even and odd functions? Generally, we consider a real valued function to be even or odd. To identify if a function is even or odd, we plug in minus x in the place of x into the function f of x, as we have seen in the previous slide. That is to check the output value of f of minus x, determine the type of the function. Even and odd functions are symmetrically determined. So first of all, definition of even function. We will see a particular definition of even function. So a function whose graph is symmetric about the y-axis is said to be even function. If the graph of the even function is symmetric along y-axis, then it is known as even function. And also f of minus x equal to f of x. So see, for a real valued function f of x, when the output value of f of minus x is the same as f of x, for all values of x in the domain of f, the function is said to be an even function. An even function should hold the following equation: f of minus x equal to f of x for all the values of x in domain of f, where domain of f denotes the domain of the function f. In other words, we can say that the equation f of minus x minus f of x equal to 0 holds an even function for all x. Let us consider an example: f of x equal to x square. So if we put f of minus x, that means we are replacing x by minus x. So f of minus x equal to minus x whole square. That in turn gives you x square. For all values of x, as the squares of a negative number is same as the square of a positive value of the number, that implies f of minus x equal to f of x for all x. Hence, f of x equal to x square is an even function. Similarly, functions like x power 4, x power 6, x power 8, etc. are also even functions. So if we want to determine algebraically, we can substitute x as, we can replace x as minus x, and we can check whether f of x is equal to f of minus x or not. If it is equal, it is said to be even function, otherwise it is not an even function. And if we want to check it graphically, we can check by drawing its graph, and if the graph is symmetric along the y-axis, we can say it as even function. Now let us see what is odd function. A function whose graph has point symmetry about the origin, that is, from the origin there is a symmetry, and f of minus x equal to minus f of x. So that means we can say opposite output value for opposite input values. So let us see what is odd function. For a real valued function f of x, when the output value of f of minus x is the same as the negative of f of x, for all values of x in the domain of f, the function is said to be an odd function. An odd function should hold the following equation, that is, f of minus x is equals to minus of f of x for all values of x in domain of f, where d of f denotes the domain of the function f. In other words, we can say that the equation f of minus x plus f of x equal to 0 holds for an odd function. For example, let us consider f of x equal to x cube. So if we replace x as minus x, so we will get minus x cube for all values of x, as the cube of a negative number is same as the negative of the cube of the positive number. So this implies f of minus x equal to minus f of x for all x. Hence f of x equal to x cube is an odd function. Similarly, functions like x power 5, x power 7, x power 9, etc. odd functions. That means x to the power of an odd number is also an odd function. So what if both even and odd functions? A real valued function f of x is said to be both even and odd function if it satisfies f of minus x equal to f of x and f of minus x equal to minus f of x for all values of x in the domain of the function f of x. There is only one function which is both even and odd function, and that is the zero function, that is f of x equal to 0 if for all values of x. We know that for a zero function f of minus x equal to minus f of x equal to f of x equal to 0 for all values of x. Hence f of x equal to 0 is an even and odd function. That means f of equal to 0, that is 0 function is an even function as well as odd function. Since if we substitute minus x or x, we will get 0 only. So we can consider it as odd function as well as even function. Next, neither even nor odd. So some functions may be neither even functions and nor be odd functions. That is, a real valued function f of x is said to be neither even nor odd if it does not satisfy f of minus x equal to f of x and f of minus x equal to minus of f of x for at least one value of x in the domain of the function f of x. Let us consider an example to understand the definition better. Consider f of x equal to 2x power 5 plus 3x square plus 1. So f of minus x equal to 2 into minus x power 5 plus 3 into minus x whole square plus 1. It will give you a function which is neither equal to f of x nor equal to minus of f of x. So hence we cannot determine it is even or odd. So such kind of functions are said to be neither even nor odd functions. Even and odd functions in trigonometry. So let us see what are the even functions and odd functions in trigonometry. We have 6 trigonometric ratios, that are sine, cosine, tangent, cotangent, cosecant and secant. So these trigonometric ratios give positive values in different quadrants for various measures of angles. In the first quadrant, where x and y coordinates are all positive, all 6 trigonometric ratios have positive values. In the second quadrant, only sine and cosecant are positive. In the third quadrant, we can see tangent and cotangent are positive. In the fourth quadrant, only cosine and secant are positive. Based on these signs, we will categorize them as even and odd functions. If a trigonometric ratio is even or odd, can be checked through a unit circle and angle. Measured in anti-clockwise direction is positive angle, whereas angle measured in the clockwise direction is a negative angle. So sin theta, if we take it as y, so minus of sin theta of minus theta will give you minus y. Therefore sin theta is an odd function. Similarly, cos theta is an even function since it gives cos of minus theta is also cos theta. Tan theta is also an odd function. Cot theta is also an odd function. Cosecant theta is also an odd function. So we can categorize, except cos theta and secant theta, all the trigonometric ratios are odd functions. Next, integral properties of even and odd functions. The integral of a function gives the area below the curve. We use properties of even and odd functions while solving definite integrals. For that, we need to know the limits of the integral and the nature of the function. If the function is even or odd and the interval is minus a to a, we can apply the following 2 rules. When the function is even and the interval is integration of minus a to a f of x dx, so when the function f of x is said to be even, then we can write it as 2 times of integral 0 to a f of x dx. It is same as integral of 0 to a f of x dx, but 2 times. When the function is odd, we can say integration of minus a to a f of x dx equal to 0. So it will simplify. So these are the integral properties of even functions and odd functions. Even functions, it will twice the limits from 0 to a, whereas in odd function it will give you 0. So let us discuss the graphs of even function and odd function. The graph of even function is symmetric with respect to y-axis as discussed earlier. In other words, the graph of an even function remains the same after reflection about the y-axis. For any two opposite input values of x, the function value will remain the same all along the curve. That means for two input values we have a single output. whereas the graph of an odd function is symmetric with respect to origin. In other words, the graph of an odd function is at the same distance from the origin but in the opposite direction. For any two opposite input values of x, the function has opposite values of y. So these are the graphs of even functions and odd functions. Here we can see that we have two values of output for same input. Sorry, we have one input and two inputs and same output in even function, whereas in odd function we can see equal distance. So let us discuss what are the properties of even and odd function. The sum of two even function is even and the sum of two odd function is odd. The difference between two even function is even and the difference between two odd function is odd. These are the important properties. The sum of an even and odd function is neither even nor odd unless one of them is a zero function. The product of two even functions is even and the product of two odd function is also an even function. The product of an even and an odd function is odd function. The quotient of two even functions is even and the quotient of two odd functions is also an even function. The quotient of an even and an odd function is odd. The composition of two functions is even and the composition of two odd functions is odd. The composition of an even and an odd function is even. Next, the important points of even and odd functions. A function f of x is even if f of minus x equal to f of x for all values of x in the domain D of f, and it is said to be odd if f of minus x equal to minus f of x for all values of x. In trigonometry, cos theta and secant theta are even functions, and sin theta, cosecant theta, tan theta, cot theta are odd functions, as we have discussed earlier. The graph of even function is symmetric with respect to the y-axis, and the graph of an odd function is symmetric about the origin, as we have seen in the picture here. Even function graph and odd function graph, which is symmetric to the y-axis. Even function graph is symmetric to the y-axis, whereas odd function graph is symmetric to the origin. Last point is f of x equal to 0 is the only function that is an even as well as odd function. So what is the difference between odd function and even function? F of minus x equal to f of x. Function is unchanged when reflected about the y-axis. Function is unchanged when rotated 180 degrees about the origin in odd function. Whereas in even function, function is unchanged when the reflected about the y-axis.